live on YouTube as well. So give us a few minutes while we get people into the event, while we announce it on X and on LinkedIn and on our community Slack, which if you're not part of, you should join, and on Telegram. So give us a few moments while I click through the buttons. And Alexei, if you have anything you want to say, or Mark, please feel free.
Welcome to our release webinar. Welcome our attendees, especially regular attendees. I see a lot of people joining. We will start in about 3 minutes. And now let me welcome Alexei. Welcome Alon. Nice to see you again. Welcome Antonov. What a nice name. Welcome Balamurugan. Sorry if I'm pronouncing it incorrectly. I have to get used. Welcome Diana, Don, Eldad, Francisco, Graham, Habibullah. Welcome Lucas, Paul, Ramazan Polat. Nice to see you again. Nice to see you regularly. Welcome Scott. Welcome Todd, Vasily, Vern. So before we start, I'm curious, what is the weather today in your location? Tyler, where are you today?
Yeah, so I'm in Amsterdam. I'm not just in Amsterdam, I'm on the 5th floor of a building built in the 1600s in Amsterdam. So the weather I would describe as uncomfortably hot. It's 31 degrees outside and 28 inside the office. The fan that's running there isn't quite enough to keep me sane at the moment.
Okay, welcome, Sai.
Thanks, Alexei. Very nice to meet you. I've never met you in person, and very glad to talk to you. So, yeah.
Yeah, by the way, where are you located today?
I'm based in the Bay Area, San Carlos, California. So the weather is kind of sunny. I think it's like just like clouds are like getting away, so it's getting sunny. So, yeah.
It should be sunny in San Carlos all the time.
Yes. Yep.
What about you? Where are you? It looks like you are in a classic hospital, judging
Yeah,
by your background.
that's my hospital room. I'm in London, and it's 31 degrees here as well. It's the same temperature as for Tyler. And London doesn't do heat, which I guess most of the Western countries, European countries, are not very good at hot weather. No air conditioning anywhere.
Okay, so you still have 1 minute for your friends to join. We are streaming on YouTube, so if your friends don't prefer Zoom, they are feel free to watch on YouTube.
Yeah, and I'll drop the YouTube link in chat here in just a moment. As a reminder, we do have the Q&A section here in Zoom. Please feel free to use it. Typically at the end, we do the best to leave our time, or do our best rather, for questions and answers. Look forward to answering your questions as they come in. Also, for those of you who are watching right now on YouTube, Mark, who's here on my screen, I think he might be there on the YouTube screen. He's keeping an eye on chat as well as I. We'll gather your questions. We try to leave time at the end to answer them. Also, always feel free to hit us up on Twitter, on LinkedIn, on our community Slack, clickhouse.com/Slack. For now, though, I think Mark, myself, Sai will stop our video, and Alexei, we're going to hand it off to you to walk us through what's new in 24.7.
Okay, let's check it. What do we have? So, ClickHouse 24.7. It is ClickHouse summer release. We will spend most of the time for new features. We also have a guest talk today, and I hope we will have just a few minutes for questions. We have 18 new features, 12 performance optimizations, and 76 bug fixes. Let me try to cover most of it. So what about new features? First of all, we have a few new nice functions. A few functions for date and time. They are named change year, change month, change day, change hour, minute, and second. And it is easy to understand, it is easy to use. Given a date and another value of, say, month, you can simply change, say, June to July, or change a hour in date time. It is easy. If you have a month with like 31 days, like in July, and you want to change to June, there is no 31st June, so it will wrap to 1st of July. It's pretty obvious, easy to use, and nice to have. Another function, this is an aggregate function, group concat. It is simple. It will simply concatenate all the values as strings. You can specify a separator like a comma and white space. It will be put in the middle between the values, and you have to specify it like additional parameter in additional pair of parentheses. Actually, this function is unnecessary because even in previous versions, you can simply write array string concat of group array of what do you want. It is actually not so simple. One function will create an array and another will translate this array to a string. So in the new version, it will be faster to write and it will run faster. Yet another function, and this is another kind of functions, a window function, named %rank. And what it does, it will return you a percentile of a particular value in a particular window in particular order. So you can split your data into a number of partitions, order data inside each partition, and check what is the rank of a particular value. But this rank will be from 0 to 1. So it is named %rank. Actually, I don't know why %, because if %, it has to be from 0 to 100, but actually it is from 0 to 1. I will show you an example. And actually, this function is also not strictly needed because in the previous version, you can write it like this. We have a window function rank that will return the rank from 1, 2, 3, etc. And you can calculate it, subtract 1, and divide by cumulative count. So you can write this. But frankly speaking, I prefer this over that. Let's take a look. So let's play a little bit with this function. So we will generate a random number, 20 random numbers. We will split them into two partitions, odd and even numbers, order by these numbers, and calculate a percentage rank. And we will use another function bar just to visualize this data. And if you look at the original data X, you will have this type of distribution. So it is random, it is uniformly random, but not so uniformly if you just do what is named Quantile Transform. quantile transformation. So if you replace every value to its rank, it will be strictly uniform like this. So it is nice to have. Let's go on. What else do we have? We have a few new system tables for introspection. Let's take a look. The new system table is named system.errorlog, and it contains a log about errors. But okay, let me clarify first. Actually, we have a lot of system tables already, and many of them could be used to get some information about error messages, about exceptions, or maybe just warnings, maybe some other type of errors. I will tell about each of these tables, and also I will demonstrate it on production on just a random server. So here is a random server, localhost port 8124. Actually, it is not on my local host. I have a port forwarded to another server. So it works. And let me show you different tables. So the first table is named system.events. And it contains the values of each metric from the beginning of server start time. And we have a lot of different metrics like the number of queries, the number of select queries, insert queries, and many different metrics. And there is a particular metric named log error. So if I will do this query, I will simply get the number of errors since server startup. Okay, actually, I have another table precisely for this purpose. It is named system.errors. And it contains for every type of error its code, the number of times it happened, the last time, the last error message, and even stack trace. You can even translate this stack trace into function names. So it is pretty interesting table. And by the way, what is the most frequent error? No replica has part. Okay, probably I have to cancel this webinar and go to investigate my production. But don't worry, it is actually not a production. It is just a random server I created for experiments. So you don't have to worry. Okay, another table is named system.metric.log. And in contrast to all other tables, if a table named something _log, it will be persistent. So the data will be recorded, logged into this table, and saved, and it will survive server restart, so it will contain historical data. And this system metric log table contains information about the the value of every metric every second. Let's take a look. And for every second, we have a number of times any error happened. So, like this morning, some errors happened 2 times. Okay, it is also a nice table if you want to draw some diagrams for monitoring. And there is yet another table named system.textlog. It is my favorite. let's take a look. But first, let me just do something like this. It contains just server logs from its startup. It contains everything. And also it contains a field named level. And among different levels, there is the error level. So I can also use this table to get information about errors. And here they are. Unknown table expression identifier system. It was the error from me this morning. Okay, all these tables are already available in previous version. And now we have one new table, system.errorlog. Let's take a look. And it contains the number of times each type of error happened each second. So yes, this is just another table. How unexciting. But okay, let's go on. What else do we have? Another table named system.detached tables. Every time you do detach table to temporarily or permanently remove table from the database catalog without dropping this table, the information about this table will appear in the system.detached tables table. So it is pretty advanced. Probably you don't need this system table, but if you do, you will be happy that you have it. Okay. What else? A few more interesting things. A new table engine named Azure Q. It is very similar to another table engine named S3Q. And both of them are for streaming consumption of data from either S3 or Azure. So let's suppose you have a bucket in Azure and someone continuously pushing new files to this bucket. And you want to process all these files. And it is easy if you want to process it once. But if you want to continuously subscribe and process every new file, Azure Q is a table engine for you. So you create an Azure Q, you specify parameters of consumption. There are two modes named ordered and unordered. If your files are named in lexicographical order, like with ordered by time, you choose the ordered mode. And in every other case, you choose unordered mode. It will simply record all processed files. And you can create materialized view over this table that will subscribe to it and continuously push data into another table. So you just create a data pipeline from Azure in ClickHouse. So you don't need to do any other tools. You don't need to do, actually it is something like ETL, ELT, I don't know, whatever. But actually all you need is just ClickHouse. Another interesting feature is automatic creation of named tuples. So in ClickHouse, there is a data type named tuple, and it is a container for other data types. It can contain any number of any data types, like string and integer. And it is easy to create this value in a query, just put it in braces and it will be a tuple. There is also a named tuple. It looks like a structure. So you not only specify the types, but you also specify the names. And in the new version, creation of named tuple is easy. Just specify an alias for every tuple element, and it will be a named tuple. And if you use a format like JSON, this named tuple will be automatically represented as a nested object. This is pretty nice to have, nice to use. Okay, what else? If you used Delta Lake tables, actually we have support for many data lake engines, including Iceberg, Delta Lake, and even Apache Hudi. Now Delta Lake has support for partitioning. In the recent versions, it was possible only to read the columns that are physically present in the data. But some columns can be used for partitions and they are not presented in the data. They are only presented in the metadata and the path. Now it works. It is easy to use, easy to read. By the way, let me quickly ask everyone, which data lake engine, data lake format do you prefer? Which one we should invest the most of our efforts? Mark, what do you prefer? Iceberg, Delta Lake, or Hudi?
I don't know. Everybody likes Iceberg, don't they? So I suppose Iceberg.
But
Come on, everybody, compete with Iceberg. Let's if you're there, write in the chat what your favorite one is. Let's see whether we got any agreement. All right, we got Iceberg, we got Delta Lake. Only got two. There's 1-1 at the moment.
Okay.
Come on, we need someone to break the tie. We've got another Delta Lake. Delta Lake's winning.
Tyler, what
Andy
do you...
says no one uses data lakes.
Actually, you don't have to use Delta Lake, whatever data lakes, because having data in ClickHouse and merge three tables is strictly better. Tyler, what do you prefer? Apache,
Yeah,
Hudi,
see,
whatever.
see, for me, Hudi was designed to solve a very specific problem for a very specific company in Uber as a Spark ingest initially as a Spark library. And so for me, I was like, I never want to lean towards the Hudi direction. And then because I'm old and a bit of a curmudgeon, I was like, Delta Lake is where I'm going to live. And then enough people started talking Iceberg that I thought maybe I should look at it. And so, yeah, I mean, fundamentally, it's whatever people use, but Iceberg is probably what I end up talking about most.
You make me even more confused. So all of them were created to solve a very specific problem, and the problem is named not invented here. Okay, so that Delta Lake support became better, and that's it. What about performance improvements? The first one is faster conversion of integers to strings. It is a classic problem just to print a number. So you have a number like 1, 2, 3, and you want just to print it to the user or convert it to string or put it into JSON. And how to do it faster? Actually, the best way is to not convert anything to string, just to leave it in a binary format. But if we have to convert to string, now we do it from 10 to 20% faster. Let me try to show you some demo. I will copy paste queries and see how faster they became. And here are my queries. I will run the previous ClickHouse version 24.6. And I will do a few synthetic queries. We will generate random numbers, convert them to strings, then do nothing about it, and just count what will be the speed. And let me ask our experts. Mark, what do you think? How many numbers per second we will be able to process?
Oh, this is a good. How many numbers a second?
Yeah,
Uh,
and yeah, how
let's
many?
say 1,000,000.
1,000,000. Aim higher.
Higher?
Be optimistic. Why just 1,000,000? Just 1,000,000 numbers. Oh,
Just not okay. Yeah, but you. So what? It has to do 2 string on it on the random number for every time
yeah, every
as
time
well.
we will generate a random number. It will be unit 32, by the way, and convert it to string.
And then ignore it.
Yeah, then just ignore, but the calculation will be still
Okay.
done.
I don't know. Okay, so not 1,000,000. How much higher? 5,000,000?
Okay, 5,000,000.
All right. So
Yeah,
come on, other people. We need some more guesses. It can't be only me. Otherwise, we only got one number.
yeah.
We're not doing good. I'm not being very successful with the audience interaction for you today.
Let me also ask Sai. Sai, what do you think about this particular query? It is multi-threaded, by the way.
And then what was the specific question, Alexei? Like it's multi-threaded and like, can you repeat the question if that's okay?
Yeah, this query has to generate random numbers and them to how many numbers per second it will process.
That's a great question. And I mean, how many numbers per second? That's a good question. And I'm thinking that like it will be like millions, right? Like would be my guess because it's all pushed down, like, and it's like all compute, right? Like, and at least like millions per second. Alexei, I'm curious what you'd say.
I would say that in ClickHouse, you don't think millions, you think billions.
I love that.
Tanya says, how many cores and threads have you got on that machine?
I would not say you have to get.
Don't make it too easy.
Yeah.
Come on, let's run it.
Yeah, let's run it. Do we have any more guesses in the chat?
Everyone's refusing until you suggest the cores and threads.
And by the way, like, I mean, the millions per second is coming from like what I have seen at Postgres, Alexei. Like, I mean, we can like stretch Postgres to like, you know, at least pushing it to the compute, right? Like millions per second is on the higher end. So it's coming from that. So, yeah.
Okay, we've got a guess, 2 billion. Well, yeah, I mean, Sai, you just need to say 5,000,001 and then you'll beat me.
Okay.
Oh, I think Gert is going to win. Gert said 2 billion and it's 5 billion.
Yeah, 5.2
Wow.
billion
Numbers.
records per second. Okay, and this was the previous version. What about the new version?
Oh, that was the slow version.
Yeah, supposedly slow. Maybe I will be
Slow
surprised.
in quotes.
Let me check.
Here we go. Wait. So what's it going to be now? 10? Nearly 6.
6.
6. So 20%
records
higher.
per second.
Nice.
This is just amazing. And you know, probably I have too slow memory.
So do you think it will be higher than this if you pick a different machine?
Yeah, it should be higher. And frankly speaking, I think it should be higher with DDR5 memory, but I have DDR4. So
now that we all lost, are you going to tell us what your system config was or is?
just 64 cores, a normal machine. Okay, it was just a synthetic query, not interesting about random numbers. Typically, you should not use random numbers, uniformly random numbers, to measure the performance, because it will not account the branch prediction, etc. So let's do another query. Half of the numbers will be just 0. And in the new version, it is. Now this query uses only a single CPU core. So here we have 107 million records per second on the new version.
Wait, what did you do to make it use only one core?
System.numbers and system.numbers MT. If you add MT, it will use multiple cores. You can also write set max threads to 1.
Okay, how they both do the same thing.
And in the previous version, it is slightly slower, like 10% slower. Okay, this was just one performance optimization. What about another one? I promised that in every ClickHouse release, we will optimize joins. And we commit to that. The first optimization is an optimization for parallel hash join algorithm. And again, I have to show you a demo. Now let me run ClickHouse server on my machine. Here it is. It's started. And I have some tables. I have a table named hits, containing almost 100 million records. And let me do self-join of this table on itself. I will join by IP address. One is the TCP IP address, and another is the proxy forwarded IP address. So let me just run it with the default settings. $100 million records, 12 million records per second. Actually, it is not so fast. It took 9 seconds. Let me make it faster, and it is easy. I just write set join algorithm equals to parallel hash. Okay, how many times it will be faster? Let me first ask Tyler. Tyler, how many times it should be faster?
Sorry, I'm clicking the wrong button for the for this join.
Yeah.
I would expect that we would only be demoing it if we were excited and that it's 2 to 5 times faster.
Okay, Mark, what do you think?
Well, I think the slide said it was about 2 times faster.
I have to run it.
All
To
right,
prove
here we
that
go.
both of you are wrong. Sai,
So what are we saying? Less than 5 seconds?
What is the number of like cores?
So it took 9.3 seconds with the existing join algorithm, and the question is, how long is it going to take with the improved parallel, or is it implemented parallel hash?
Yeah, the question is correct. It's a good question. How many cores do I have? 64 cores, but it is not necessarily to parallelize 64 times.
Yeah. And is there like a ClickHouse setting that controls this, like this parallelism or something?
Yeah,
I would guess like
it's like 5 lines
Okay.
up. Set join algorithm equals parallel hash. I think that's what's the
yeah. And like, is there like a number of threads or something that will control this or nothing?
Yeah, there is, but by default it is set to the total number of cores. Okay, let me run it.
100x, 1000x?
1 second. So,
Nine times faster. Tyler's
9
the winner.
times. Okay, awesome.
okay. So yes, it is faster. But there is one trick. If I run this query again, it will be even faster.
Cached. Yeah.
The reason is the cache. But actually, it is a different kind of cache. It is not a file system cache. It is not like internal buffers. It is a special cache about runtime statistics of the sizes of a hash table. So the first query has to guess what the hash table will be, and it allocates a small hash table, resizes it, resizes. The second table will just remember the previous one and resize straight to the correct size. And it is another 1.5 times faster.
Does it only remember that for like a certain amount of time and then it kind of goes away or it will remember it forever?
Okay.
No, does it? The question, like the cache, this remembering the size of the table, does it keep that around just for a certain number of seconds or?
It keeps it forever, but there is a limit on the total number of the entries, and this limit is quite generous, like 1 million or something like this. And it will persist before server restart.
So this parallel hash, this is not the default at the moment.
Yeah, currently it is not the default. We want to make it a default. And currently, if you set it to parallel hash, 99% that all your queries will just improve, and you should do it. But we cannot make it by default because we have like tens of thousands of different services in production. And what if just 1% of the services will slightly degrade? We want to make it better in 100% of times, no less.
How will you know when you've got it better in 100% of cases? Is that how do you work that out?
We will just make it for our customer, for every service in production. Maybe there will be a new service that will not benefit from this setting. But anyway, at least they will not get degradation. Okay, yet another optimization for as of join. You, Mark, definitely know what is as of join, but not everyone. So as of join is a special method of joining that finds not a strictly matching record, but closest match, say closest by time. In this example, we join hits or page views, you can say, with sessions. And we join by strict equality of user ID. And for each user ID, we will choose a single record with event time of the page view more than event time of the session. And we will choose the first record by time. It is a pretty nice feature. It appeared in ClickHouse in 2019, before all other SQL databases. And it works quite well. And the new feature is the support for full sorting merge algorithm. Again, let me quickly show you a demo. And I will do a self-join of the hits table by user ID. Okay, let me try it. It is slow. 5 million, 6 million records per second.
When it's computing the as of join, how does it decide the order of which one it looks at first? Like, does it look at the user ID first or the event time first? Like, does it have to be like, can it be any? Can you do any clause there, or does there have to be one where it's equals and then one where it's time, or could you just have a time on its own?
If I recall correctly, but actually, why should I recall? I should just test it like this, right?
Yeah.
Yeah, as O
Okay,
join.
so you need one equality condition.
I don't know why. If I write like this, will it work? No.
Oh, interesting.
But you know what? I can cheat. The function ignore will always return 0. And now it does what I
See,
want.
this is like the extra trick that everybody gets to learn, the ignore function. I've not seen that one before. That's a cool one.
No, please don't learn this trick. I don't
Oh.
like tricks.
Bad trick.
I prefer if everything works naturally. So we have to fix it. But okay, it wasted 17 seconds. Now what I will do is I will set join algorithm to full sorting merge. And guess what? It is so much faster. Not so much. 7 seconds. It's about 2.5 times faster. Okay, another performance optimization. An optimization for reading tables in order. So when you create a table, you specify an order by key. And the table will be almost physically sorted by this key. If you specify a prefix of this key or something like a function of this key in the order by condition in the select query, it will read in order, literally. Let me check it. So, first of all, I will look how it is in the new version. 0.4 seconds. Let me also remove the output like this. 100 milliseconds. And this is only because it was improved in the new version. It was optimized. I can turn on the old behavior and check how slow it was before. And it was 9 times slower. So it is a pretty good optimization from 1.5 gigabytes per second to 14 gigabytes per second.
Does that only apply like for if you're returning the column straight away? Like what would happen if you did, I don't know, like count count something as well as ordering by counter ID? I guess does each counter only appear one time? Maybe it doesn't.
If
maybe it
you
doesn't
read
make sense.
from a table with ordering, it will benefit from these optimizations as long as you also have a highly selective condition. Actually, this optimization is not so simple, but just remember, 10 times faster. This is all you have to know. Install the new ClickHouse version today. Another optimization. Load balancing of connections to ClickHouse Keeper with respect to availability zones. It works like this. In the ClickHouse Keeper configuration, you can specify the availability zone in a form of arbitrary string, or you can specify auto detection from AWS IMDS. It will automatically get the name of availability zone, and it will just make it available for ClickHouse server. And in ClickHouse server, you can also configure the availability zone and also configure that it should prefer local ClickHouse keeper. And if it was connected to suboptimal keeper in another availability zone, after some time that you can also specify, it will just reconnect, and it will save network latency, network cost, and everything will work faster. Okay, let's discuss something interesting. The first one is about startup scripts. Now it is possible to configure some commands that the server will run before accepting connections. You can create roles, create users. You don't have to configure it in XML files. You can use SQL queries. And the server does not have to be ready. It does not have to run. It will first run these scripts and only then accept connections from the users. And this is the whole point. Okay, this feature is really interesting. On disk storage for keeper. So what is ClickHouse Keeper? It is a replacement for Zookeeper that is faster, more efficient, more stable, and easier to use. But typically for every similar systems like Zookeeper, ClickHouse Keeper, etcd, console, they all require the data set to fit in memory. They are actually in-memory databases. And if you have billions of values, if you have misfortune to have billions of values in a distributed consensus system, you will have to scale it to a lot of memory, like hundreds of gigabytes. But maybe you don't want to. And now it is possible to specify a single option. It is experimental for now, and it is named experimental use RocksDB. With this option, Keeper will work slightly slower, actually 2 to 3 times slower, because it will store data on disk. But it will no longer require a lot of memory. It will use just a limited amount of memory for any data size. It looks like a magic solution. So I advise, if you will test it, if you will share your feedback, it will be very nice to see. Yet another feature, the proper deduplication for materialized views. So let me explain what it is. In ClickHouse, inserts are idempotent. It means that if you inserted a batch of data and you don't know if it was inserted or not inserted, you can just repeat this insertion. And if it was not inserted, it will be inserted. If it was inserted, the new insertion will be ignored, so deduplicated. And you will get exactly one's semantics. You can also specify a user-provided deduplication token instead of the hash of chunk of data. So it will be used for deduplication. But the question is, what will happen if there is actually a chain or a graph of tables with materialized views? You have a table and you have a pipeline that will process this data and push to another table. And it can push to yet another table, and so on. In previous versions, there was no guarantee of exactly one's semantic for materialized views. It was for the main table, but not for dependent tables. And in the new version, it does very smart stuff. It calculates a tree of hashes and use them to deduplicate everything correctly based on the original data chunk or original deduplication token. And yet another feature, maybe for experts, maybe for everyone. A setting to choose the consistency behavior of projections in the presence of lightweight delete operations. So projection is the same data of the same table stored in a different order or a different aggregation to automatically optimize queries. You can aggregate data in a projection, and your queries that select aggregation will automatically use this projection. And in the previous ClickHouse version, there was one small problem. If you delete some records, this deletion is not represented in projections. Projections still make deleted records visible. And it is understandable because if it is an aggregation, it is not possible to just get out single records from the aggregation. In the new ClickHouse version, you can just specify a setting for your table to choose the mode, and the mode will be simply invalidate the projection, so the queries will not use it and will not be optimized, or throw exception to prevent deletes. Okay, and let me proceed to something really interesting. And now let me invite our guest. Our guest today is Sai. Welcome, Sai.
Thanks, Alexei. Great to be here.
Yeah.
Awesome. We can get started. So today I'll be talking about PIDB, which is a technology that enables you to seamlessly move data from Postgres to ClickHouse. And as you folks might have seen today, there was an official announcement that ClickHouse has acquired PIDB. And this is to basically, at a high level, bring both databases, which is Postgres and ClickHouse, together, right? Like, and just for some background, a quick intro about myself. And I'm Sai, and I'm the CEO and co-founder of PIDB. And prior to PIDB, I was working at Microsoft, and I was leading the solutions engineering team for all Postgres services on Azure. Prior to that, I worked at a database startup called Citus Data, which built like a distributed Postgres database. And which is when I first heard like ClickHouse, because Cloudflare, who is one of the large customers, large users of ClickHouse, was previously using Citus, right? And then they migrated to ClickHouse. That's a quick background about myself. So my life has been mostly in Postgres, right? And I started this company PIDB around like close to 1 year, 3 months ago, with the with the singular focus to build like the world's fastest replication experience from Postgres to data warehouses, right? And which is where ClickHouse came into the picture, right? Like, and for the past like 6 months, like we have the ClickHouse connector, right? Like, and a bunch of users, both open source and like paid, right? And by the way, PIDB is also open source, right? Like it is, so you can use it, like you can deploy it in like few minutes and get going and seamlessly move data from Postgres to ClickHouse. And the use cases we see are real-time analytics, right? Where you have your OLTP application running on Postgres, and you want to continuously replicate that to ClickHouse and offload like real-time analytics. Some customers use for like data warehousing, where like ClickHouse is their like centralized data warehouse, and they have Postgres, which is their system of record like database, and they replicate that to ClickHouse for offloading analytics, right? So yeah, I mean, PIDB can be used for like continuous replication from Postgres to ClickHouse. That is one use case. Or also for like online migrations, right? Where you want to replicate data seamlessly, and then with very minimal downtime, you can migrate your like analytical use cases from Postgres to ClickHouse. So that's a quick background about like PIDB. Now, the magic sauce, right? Like the value proposition is we built like we implemented a bunch of like Postgres native optimizations to make the data movement experience, the replication experience 10 times faster and significantly more reliable, right? Like, so if you have like hundreds of gigabytes, like terabytes of data, you can use PIDB to move data very seamlessly. and a few optimizations that we do. And you can take a look at our website, a bunch of like blogs around what optimizations we do. One thing I'd like to call out is we do something called as parallel snapshotting, right? Like which what we do is like under the covers on the Postgres side, if you have like a super large table, right? Like we partition that table based on tuple identifiers, and Postgres has this concept of tuple identifier, which represents a row directly on disk, right? So we partition that table based on tuple identifiers. This is logical partitioning, right? And then stream these partitions in parallel to ClickHouse, right? And the reason, like, and the benefit of this is you'll be able to move terabytes of data in few hours versus days from Postgres to ClickHouse, right? And the reason is, one is we are parallelizing the load, right? And number two is we are directly reading from disk. So like data is being read on how it is stored in disk, right? So this is one optimization. The other optimization we do is like around logical replication. So Postgres has this concept of logical replication, which is responsible for like, you know, change data capture, right? So as inserts, updates, and deletes happen, you can replicate them to ClickHouse. So we do a bunch of optimizations there where we always consume the replication slot. So if you don't consume the replication slot, that can crash the, you know, a Postgres database, right? So we do a bunch of optimizations there as well to de-risk like load on the source Postgres database, and also improve performance. For example, one feature that we're working on as we speak is consuming ongoing transactions, right? So currently, like, you know, by the standard ETL tools, just like consume, you know, once the transaction is finished on the Postgres side. Now with this like feature, it's a big feature that's like, you know, there is a draft PR also on the open source repository. What that does is it like consumes ongoing transactions. That helps like better throughput, better latency, further de-risks like load on the source because your application slot growth will be minimal, right? But at a high level, right, like, you know, we do a bunch of optimizations on the Postgres side and also on the ClickHouse side to provide like a 10x faster and a more reliable like replication experience. So yeah, that's a bit about PaDB. And in this session, I wanted to get right into a demo, right? Like show the product, because I'm also a very like hands-on kind of a person. So let me share my screen and feel free to post any questions as they come up. So yeah.
Yeah, it will be very interesting. Very interesting to see.
Awesome. So one fun thing that I did, right? Like before I go into PaDB, I was just running like, how long will it take to generate like 10 million rows on Postgres, right? Like, and I realized that it takes around like close to a second, right? So this is like 10 million rows close to a second. And then Alexei showed a demo where like, you know, in ClickHouse, we were able to generate around over 5 billion, numbers, right? Random numbers. But anyways, this is a separate thing, but let's go to PaDB, right? So I have a Postgres database, which is running, and I have a table called events, right? Like, and if you see the events table has a bunch of columns, right? Like it also has a JSON B column. It has a primary key, which is ID, etc., right? And it has around 1 million rows. So let's quickly run a count and check that like there are 1 million rows, right? Now the goal is to replicate this table to ClickHouse and also show you the continuous replication where I'll keep adding more rows to Postgres, and let's see them replicated to ClickHouse, right? And this Postgres database is running on the cloud, right? It's running on Azure, and it can run anywhere, right? It can be open source, it can be any other managed service, right? Like it can be anywhere, right? Same with ClickHouse, it can be ClickHouse Cloud, it can be like ClickHouse open source, it can be anywhere, right? So I have ClickHouse, which is running on the cloud, right? Like I have a ClickHouse instance, right? Like which is running on the cloud. PaDB has a concept of peers, which are like data stores, basically, right? So before this demo, I created like 2 peers, like the Postgres peer and the ClickHouse peer, basically. And this is basically, you know, making a PaDB aware of, okay, these are my data sources, right? These are my data sources where I want to start my replication jobs, right? Then PaDB has a concept of mirrors, and mirrors are nothing but replication jobs, right? So it's similar to mirroring your data, right? And there are 3 types of mirrors that PaDB has. Like you have the change data capture based mirror, query replication based mirrors, and XMIN. I won't go into the XMIN bit as of now. Change data capture is the standard like approach of replicating data, and it lets you replicate all the DML operations, which is the inserts, updates, deletes, and also DDL operations where you add a new column, you can replicate that also to ClickHouse, right? Then you have like query-based replication, which is where you can run a query, right? As you're seeing here, right? Like, you can run any query, right? Like, let it be joins, let it be like, whatever, right? Like, and then you can replicate results of this query based on a watermark column, right? And the watermark column can be like an updated ad, created ad, or like an incremental ID column, right? In this demo, I'll just show you the CDC because that's the standard approach and it minimizes the load on like the Postgres database, right? It's the more native and the default way. So let's go ahead and see that demo. So I'll name the mirror as Postgres CDC to ClickHouse, right? And I'll choose the source peer as my Postgres database. I'll choose my target peer as ClickHouse, right? And then there are a bunch of like, knobs that you could tune, right? Like on the, so there is sync interval, which defines the real-timeness of data on the target, right? Here I have 60 seconds, I'll change it to 10 seconds, right? And then there is also a setting which is called parallelism for initial load, which sets like how many threads I should use to do the initial copy of data, right? Like where move these million rows to like ClickHouse, right? And then, incrementally load data to ClickHouse, right? So, and then there are many advanced settings. I won't go into each of these, but like there are many advanced settings. One fun setting is you also have, we also support like row level transformations, right? So where you can attach like Lua scripts and do row level transformation saying that, hey, I want to obfuscate, I want to mask this column, right? Or I want to generate a new column, right? And stuff like that, right? But I won't go into that part. So let's go ahead and choose the table, right? So I have the events table and you can choose the columns. You can, exclude some columns. You can specify like the target table name, which like here I'm just calling as like, public_events. And on the ClickHouse side, right? If I just do select count star from public_events, right? And run this query, obviously there is no table yet, right? Because I have not yet kicked off the mirror, right? So I've chosen that and let me validate the mirror. So the CDC mirror is valid. So this does a bunch of like checks that like whether the PDB has the right permissions on source, right permissions on target and all of that, right? Under the covers. So let me go ahead and kick off the mirror. And okay, so the mirror is kicked off, right? And it'll take like a few seconds to come up, right? And let's give it like, few seconds. In the meantime, let's quickly go ahead and look at other things, right? Like, so there is like a UI which shows logs, right? Like if you're seeing on the screen, right? And then there is like the scripts bit, which I was talking about, right? Like the transformations. So you can write like Lua scripts, right? And then do row level transformations as your data is moving to like ClickHouse, right? Then there is alerts, right? And in alerts also, you can set alerts based on the replication slot size, which is like the main data structure on the Postgres side, which supports CDC, right? And you can set alerts saying that, okay, 50 gigs of replication slot size, I get an alert so that I check what's going on with my replication. It could be just like a high load on the source, right? Like, or it could be something wrong with the replication, right? So we give you that as well. You can set like, what are the number of connections on source, and alerts are also for errors, right? So, and you can send them to like either Slack or email, basically, right? So let's go to mirrors and let's see what's the status. Okay, so this is the mirror overview tab, right? And looks like the initial load already finished. I mean, that was pretty quick, right? And it took around 8 seconds for 1 million rows, right? And what we have seen, right? Like you can move terabytes of data in, tens of hours. So like recently we had a customer who moved like 3 terabytes in like 12 hours for the initial load, basically, which is very, very quick. And thanks to how fast like ingestion is on ClickHouse as well, right? This wouldn't have been possible with like other warehouses. So let's go ahead now and let's, check whether this table public.events is there, right? So let me move this thing and okay, the events table is there, right? Like it has 1 million rows, right? And let me refresh this page because I'll show you, the table getting created. So public.events is created, right? And it has some data if you're seeing here. And the way, and PDB took care of creating all the, right columns and under the covers, like we use replacing merge trees, right? Like the order key is the primary key, right? And the version is like, there is a version column. And based on those 2 columns, like ClickHouse does the deduplication, basically, right? So this is the data. Now let's go to the fun stuff, right? Like, and let's start inserting some data into this table. I'll insert around like 1,000 rows every 2 seconds, basically on source. And let's go ahead and see what's going on with PDB, and these should be replicated to ClickHouse pretty soon. So the real timeness I set as like 1000 as 10 seconds, right? So you should see the data. So let's go to now ClickHouse again, and let me go to this. Let me go to the query, then run the query, right? Then you're seeing like the rows already here, right? And then this should change very soon. I want to do a fun thing, and this was not in store for the demo, but I do want to do it, right? So let's go ahead and add a new column, right, to this table, right? And then let's add a new column which is like IP, which is text, right? And then let me go ahead and add this column, right, on the source, which is Postgres, and I'll go ahead and insert some data also to this. Now I'm populating the IP column, which is like 127.0.0. I have an extra O, which I will remove now. And then, so this, what I did now is I added a column, and then now I'm ingesting rows again into Postgres, right? So this shows like, the goal of this is to show you like DDL replication, basically, which is like the alter table, right? And let's go ahead and see what's going on the PDB side, right? Let's give it like 5-10 seconds. Soon the column should be there. Okay, let's go to this public.events where IP is this, right? Okay, let's give it like a second. No, where IP is equal to. Awesome, you have the data. Let's go ahead and look at that data as well. So this under the covers, like PDB took care of adding that column on like the target, right? And then also start ingesting those rows, right? And the similar experience you can expect with like updates, deletes, right? And also we show some metrics, right? And then if you see this is you can see minutely metrics and stuff like that, right? And also everything that you're doing here via the UI can be done via a Postgres compatible SQL interface, right? The idea here is, say you have like a bunch of Postgres databases, right? Like say tens of them, and you want to easily script out your pipelines and like seamlessly move data to like ClickHouse. All of this, right? Like creation of peers, creation of mirrors can be done via like a SQL API. So yeah, that's it from my side, Alexei, and I would love to take any questions.
Yeah, thank you. The main question is what happens when, how exactly updates and deletes are processed? So how they are translated into insertions, into replacing merge tree, or what?
Yeah, great question. So in regards to updates, like we basically update it with with a more recent version. So we do an insert with the recent version, and then leave it to the replacing merge tree to asynchronously, do the deduplication, right? Like based on the version and the primary key, Alexei.
Mm-hmm. And another question, I don't know why someone would need that, but is there a possibility to replicate data from ClickHouse to Postgres?
Great question. I'm also not sure why it's needed, but I probably the reason, the intent from the user is, okay, I do my roll-ups in like ClickHouse, and I want to power my like milliseconds. I want to power my like lookup kind of a workload on Postgres, right? As of now, like no, I mean like PDB doesn't support the other way around, but we can look into it. One thing is that like the Supabase guys released like ClickHouse_FDW, which you should take a look at, which actually lets you query data from Postgres, query ClickHouse data from Postgres, and you can move, you can try out that way, but FDWs are not very scalable because you do like batch inserts, and like it won't be like, it's not like CDC, right? But this is something that we will take a look at in the future. But as of now, like PDB is more built for like a Postgres to ClickHouse, Alexei.
Yeah, actually, you know what? I want to use your product. It says that I don't use Postgres, so I don't know, but it looks so nice. Okay.
Thank you, Alexei. Awesome, guys. Thank you for the opportunity.
Mm-hmm. So what else do we have? If you want to read how ClickHouse is used to improve AI, there is a blog post on our official website. You can read how to build user-facing dashboards, how to monitor ClickHouse Cloud, or how to replace Zookeeper with ClickHouse Keeper. So there is a plenty of interesting stuff. And now we have minus 10 minutes for questions. Tyler, actually, do we have time to accept at least 1 or 2 questions?
Of course. Like it's just bits streamed over the internet, and I'm sure they go into a database that can support them. So, Mark, if there's any questions that have come in, please feel free to share them.
Yeah, we've got a few. Maybe we'll go backwards from the most recent. Most recent question from Ashish. When will 24.7 be available to install? It's not in the apt repo yet.
Today, I think in a hour or 2.
Cool. Question number 2 from Alon. You might have just answered this actually, but I'll say it anyway. Will PeerDB replicate updates and deletes to ClickHouse, considering these are expensive alters in ClickHouse?
We just answered to this question.
Cool.
It will.
Yeah, absolutely. So like we don't do like alter update and alter delete because I mean it's not ClickHouse doesn't recommend that because they can be slow. So we lean on like replacing merge tree under the covers and like do inserts like for both like updates and deletes, and leave it to like the replacing merge tree engine to do the deduplication marks. Yeah.
Okay. Next one was about the restart scripts that you showed, and the question is, does it rerun the start script if you restart the server, or does it keep track of what it's run? Or what would happen, for example, if you had the start script and then you updated it and then you restarted? Like, how did this?
If I recall correctly, it will run this script every time, but
Every time
you can specify queries for conditions to run this script. So you can check if some table exists or some records present in the table, and only if a query will return just value 1, it will run another query. And obviously, you can also use something like create if not exists, etc.
Cool. And then another one for, maybe for Sai. Are there any solutions for reverse CDC, i.e. from ClickHouse to Postgres?
We just answered to this
Oh, you did that
question.
one already?
You don't,
I think we're done. I think we got
don't-
them all then.
You don't need to replicate data from ClickHouse to Postgres, but if you really want, you can use ClickHouse FDW just to query ClickHouse from Postgres, and many services have support for this.
Yep.
We've got some questions as well, which I don't think are directly related to anything we talked about, but probably you know the answer. So the first one is there a plan to support, and then in quotes, move parts to shard feature in ClickHouse?
There was such a feature proposal, but it was not in the plans for at least for the team. And currently, it is unclear if it will be in the plans or not. So not for now.
Cool. Yeah, I mean, the next question is, I think, is following on from that and saying that the Tarun who asked the question has made a PR, but I guess we can look at this offline, right? There's no don't need to address this now. Otherwise, I think we're done. Yeah, I think we've covered all the questions. So let's go back to Tyler.
Yeah, I think we have indeed. So I had the opportunity to spend a lot of time recently thinking about how we talk about PeerDB and ClickHouse joining forces. and also to think about all of the new features in 24/7. And then to talk to a number of our users to help them tell their story. And what I've realized, and I keep saying this over and over, but I'm going to share it with you, is a database is only as good as the data that is stored in it and the applications that users build around it. I find the optimization and new functions incredibly powerful, but I find them powerful because of what I expect all of you to build with them. And today is a really cool day for us as a company because Sai, who is here on this call, is joining ClickHouse, but Kaushik is joining ClickHouse, and Kunal is joining ClickHouse, and Kevin is joining ClickHouse, and Amok is joining ClickHouse, and Philip is joining ClickHouse, and Geert had an amazing answer in Slack, which I deserve you a t-shirt. Please email me. Today is an exciting day because it's not only a day where we release the next version, which gives you a wide variety of bug fixes and performance capabilities and new features, but today is the day that we announce that we've joined forces with PeerDB, which brings something super exciting to the table. We do this every month. We invite you to join us every month. We invite you to invite your friends to join us every month. For those of you who have been here, we appreciate it. For those of you who are watching the recording, if you've made it an hour and 17 minutes into it, thank you. Send me an email. I'd be happy to tell you thank you in person. And if you'd love to join us in the community, hit us up in GitHub discussions on Twitter, on LinkedIn, or in our most active community channel right now on Slack, in clickhouse.com/Slack. Other than that, we thank you immensely for joining us, and we look forward to seeing you next time. Be well, everyone.
Thank you.